Hello everyone, welcome back to the another session in Principles of Programming Languages. So we'll continue to learn about 4th unit. We were in the next chapter of 4th unit, which is exception handling. So basically 4th unit is having 4 different kind of chapters. The first is about abstraction and the second is about encapsulation. OOPS features, there we discussed about inheritance and dynamic binding. And today we'll be going to talk about exception handling. We'll wind up this 4th unit with another topic, which is logic programming languages. So these are what the basic content or the concepts which are available according to the syllabus. Now, so today we'll talk about exception handling. What do you mean by exception first of all? Let's see, when you are writing a program, irrespective of a programming language, let's think about what is an exception. Then we'll be coming across with the programming languages, how each language will deal with the exception. So basically exception is what? It is an error which occurs at runtime. So we were seeing about syntax errors, logical errors, these kind of things. So error is a mistake or error is a wrong commitment of the user while they are typing the program or they are doing the execution process. It's not maybe happened by the user, it can be even happen by the hardware. And the solution can also be given by hardware and by the user. These all the things we'll discuss. So basically exception handling is what? It's an unusual event. It's an unusual event or which caused at runtime during the program execution. So this is what a basic idea of the exception. Now let's understand about exception handling in general. So most computer hardware systems are capable of detecting certain runtime error conditions such as floating point overflow. This is the cause, or this may be one of the cause to get an unusual event while we are executing the code. So, and in the case of input and output operations, however, the situation is somewhat different. So this is what we were done with the runtime error conditions and the input output operations. So first point will tell you about, it's an unusual event which caused to runtime errors and it may be caused during with the input and output operations. So there is a language which have this problem, which is Fortran. Fortran language will be having a read statement while it is going for reading all the instructions of the program. If I do not specify, reading operation should be done until the end of the file. If I don't put that until end of the file condition, so naturally it will go for a long process. Correct? So I should terminate the read statement until it meets the end of file. So if I don't have this thing that specifying the end of file, then I will see an unusual error. There is a category of serious errors that are not detectable by hardware but can be detected by code generated by the compiler. So the first 3 points will tell us the first thing what we'll be having an unusual event which is committed by the programmer, or it can be by the hardware system, or it can be with the languages, with the statements. So even when you are writing these kind of things, there are some scenarios where even hardware system will not do it. Let's think about arrays. So arrays, while I am writing a program, if the program index or the size of the array, the subscript size of the array is gone out of the range, then hardware system will not do the solution for the same. User has to raise the problem. In the case of input and output operations also, hardware system will not do the solution. User itself, they have to write a segment which is end of the file specification to come out of the loop or read statement, not to go that statement infinite loop. So this is what unusual event and the solutions what can be made by the user, by the hardware. So this point is what basically all the unusual events will not be solvable by hardware. There should be something which has to be come from the user. So we consider both the errors detected by hardware such as disk read errors and unusual conditions such as end of file to be exceptions. So these are what the unusual event which caused during of these steps which will be detected by the hardware. And we do also some kind of things, unusual conditions, unusual statements which can also be detected by the programmer. Fine. So these are what the basic idea of exception. Now we'll see about what is an exception. The definition we'll see. Accordingly, we define exception to be an unusual event that is detectable by either hardware or software, and that may be require a special processing. This is what a definition of an exception is this. And so here we wrote a point that it has to be handled. So we will not leave, see, let's say that disk error has been occurred to the computer. We'll not leave that as it is, right? We'll be solving it, or else if I have some end of operations file error or some kind of things, we'll not leave as it is. We'll put a solution. So we'll handle that. The unusual event which is caused during of the execution, we'll handle it. That handle is nothing but a special process. That is what? The special process that may be required when an exception is detected is called exception handling. This processing is done by a code unit or a segment called an exception handler. Now, exception handling and this exception handler, the special processing which has to be handle the exception. So that will be done in few languages, that the languages are what? C based languages. So it is not C. Don't get confused that I am teaching C is having exception in something. No. C based languages. There are many languages which are based upon the C structure or C features. So that language I am specifying here. C based languages and C++, Ada, Java. These are the languages where we talk about exception. The unusual events will get handled by these kind of languages. And in some C based languages, exceptions are said to be thrown rather than raised. So this is what C giving the solution. We have to even think about, or we have to even learn about how exceptions will get handled in C++, Ada and Java as far as syllabus is concerned. Right, now before we go to see about these kind of languages, let's see about the design issues. Okay, so basically there are two kind of exceptions. So one is predefined exception, the other one is user defined exception. Predefined exception is what? These are implicitly raised. User defined exceptions must be explicitly raised. And we'll write, see, user defined, the name itself it tells that we have to define to handle that exception. What the exception it may cause and how to handle that exception. User defined exception, that user has to put into the segment, a code unit. So that is what, look at this example, void example. I am just taking this statement. We say this is what unit level or subprogram level handling the exceptions. Average is equal to sum by total. So when total becomes 0 or when sum becomes 0, then this will be having a unusual event. It throws an exception. Now how to handle this exception? To handle the exception, I am just writing a segment which I am calling with the name of exception handler. This exception handler is what? When 0 divide, average is equal to 0. Printf error divisor total is 0. We are handling that, the exception, so we will be calling it as an exception handler. The exception of division by 0, which is implicitly raised, causes control to transfer to the appropriate handler, which then executed. So this is one kind of exception. And let's see that the design issues. The first design issue, there are many design issues truly speaking, but we'll be going to take 3 design issues or primary design issues which will be carried out by every language. If I say C++ is handling the exceptions, then the 3 design issues what I am specifying in this slide has to be maintained in C++. So whatever language I specify that it is handle exceptions, so that languages will commonly acquire these three design issues. The other design issues were also there. Irrespective of languages, we say those are common issue. We say those are specific issue. These are what common issues every language has to carry it out. The next slide is going to be a specifical things that this language will be having this design issue. The other language may not have it. So in that case, we have to understand. Let's see about these three design issues, as these are what has to be maintained by everything. The first design issue for exception handling is how an exception occurrence is bound to an exception handler. So when we are writing the earlier code, you might have noticed that we just wrote one unit, one instruction in the function, and later we just wrote that exception handler, how this binding will get happened. So that is what the first design issue. And the next design issue, let me have some discussion over here. This issue occurs on two different levels. On the unit level, there is the question of how the same exception being raised at different points in a unit can be bound to different handlers within the unit. For this is the reason why our programming languages will be having a special keywords to bind the exception and exception handler that we'll see in languages. Another design issue is the following. If users are allowed to define exceptions, how are these exceptions specified? Before slide, we were come across with predefined exceptions and user defined exceptions. How can I specify it? Do I have any kind of special syntax to define these kind of predefined user defined exceptions in languages? Or else what kind of things it allows? That the part we'll see in each language. Now, the third design issue is whether hardware detectable errors can be handled by user programs. If not, all exceptions obviously are software detectable. So, this also one of the design issue, and whatever design issues I specified, that will be carried out by all the languages which said to be exception handlers. So, these are the languages, these are the design issues which varies from language to language. Let's have a look. The design issues are what? How and when, how and where are exception handlers specified and what is their scope? How is an exception occurrence bound to an exception handler? Can information about an exception be passed to the handler? So the first three is automatically covering the first design issue, if you remember, because we were writing the exception, what it is, and exception handler, how it has to specify, and binding of those two will be maintained through a keyword I told, right? So the first three design issues are prominently talking about the first design issue in the previous slide. Where does execution continue, if at all, after an exception handler completes its execution? This is the question of continuation and reception. So generally when we are writing this kind of exceptions, when execution will take place. So it's a basic question. So that also will deal in the language. The next is what is some form of finalization provided. How are user defined exceptions specified? If there are predefined exceptions, should there be default exception handlers for programs that do not provide their own? So these are what the second design issue, if you see. So we were talking about the kind of exceptions, how to be specified. The next one is, can predefined exceptions be explicitly raised? No, we'll do it is an implicitly. That's part we were seen just before, right? So most of the languages which comes under exception handlers, the languages will allow predefined exceptions as implicit, user defined exceptions under explicit. Are hardware detectable errors treated as exceptions that may be handled? Are there any predefined exceptions? Should it be possible to disable predefined exceptions? So these are what basic design issues to specify exception handlers in the programming languages. Now we'll see about the languages which provide exception handling and how exception handlers are written, how the binding will get happen, that we'll talk individually. Fine. Thank you all.